So welcome to Unit 3, Lesson 10. This is the last lesson of Unit 3. And in this lesson, we're just going to go over how to solve equations involving polynomials and exponentials using the graphing calculator. So there's just two examples we're going to go through, but there are some important calculator skills we want to review here. So in the first example, we're given two functions, f of x, which is an exponential function, and g of x, which is a quadratic because it has a highest exponent of 2. So the first question is dealing with the exponential function, and it wants to know when f of x is equal to 8,192. And again, we can't really do this algebraically because the x is in an exponent. So first we're going to set up an equation to reflect this information. So we want to know when 8,192 is equal to 2x. In order to accomplish that, we need to find the intersection of these two functions. So we're going to graph them and sketch the graph because that is what shows evidence of how the method we use to solve the problem. And we're going to graph each side of this equation as a separate graph on the calculator. So we're going to have one at y equals 8,192 and the other function as y equals 2 to the power of x. So when I graph those, I'm not going to see anything to begin with because remember, this is a horizontal line up at 8,192. So I can see the exponential function, but I can't see where it crosses. So I'm going to modify my window a little bit. I might up my x value to 20, just in case it takes more than 10, a value of 10 to get there. And I'm going to change my y max to about 8,500, just so I can see what I'm looking for. So there is my horizontal line. And then in red, I'll see my exponential function. And eventually it'll start increasing, which happens pretty rapidly. So I'm looking for the intersection point. But first, I'm going to graph that I have a function, horizontal line at 8,192, and I have an exponential function, and I'm looking for that intersection point. So I do a second trace intersect, enter 3 times, and when I do that, I see they intersect when x equals 13. So the value of x when f of x equals 8,192 is x equals 13. And all you need to show is the initial equation. So you have to show that you know to set them equal to each other, the graph and the sketch and the solution. So for b, it's very similar, but we're dealing with a quadratic function. So here we have negative x squared plus 3x plus 2. But we want to know when that function equals negative 26. So again, we're going to set them equal to each other because that shows that we understand what we're trying to achieve here. And then we're going to do it graphically. So we're going to enter in the first equation, the left side, which is negative 26, and the quadratic function, which is negative x squared plus 3x plus 2. Now, when I graph that, I still have my very large window from the first question. So it's going to attempt to graph them, but I'm not going to see much because I don't need a scale quite this large. So I'm going to reset my zoom to zoom standard to begin with, but then I realize that I have a horizontal line at y equals negative 26. So I have a parabola that comes up like this, but I also have a horizontal line at negative 26. So I'm going to change my y min to negative 30 just so I can see that horizontal line. And I should see it. And then I see my parabola coming up as well. And I'm going to graph them. So note that there are actually two solutions to this. There are two places where this function is equal to negative 26. So there's actually going to be two answers. Two x values where this occurs. So I'm going to have to do my second trace intersect twice. So the first time, I'm going to trace over closer to the left-hand point of intersection. And I'm going to see that those coordinates are negative 4 and negative 26. And then I'm going to do it again for the other point of intersection. So I'm going to trace over to the right. And when I get close enough, the calculator should be able to realize what I'm doing here. And then I'm going to press enter 3 times. And that happens at 7 and negative 26. So the solutions to g of x equals negative 26 are x equals negative 4 and x equals 7. So notice that it didn't ask for the points of intersection. It asked for the values of x, because the solution to this equation can only be values of x. There's no y in this equation, so the y values aren't part of the solution. So you need to make sure you communicate just the x's in your final answer and not the y values as well. So the final part is now saying, okay, find the solutions of when the two functions are equal to each other. So now, instead of graphing negative 26 with my quadratic function, I'm going to graph 2 to the power of x with my quadratic function. And I'll see my exponential function in blue and my quadratic function in red. And I'm going to reset the zoom so it looks a little bit easier. And remember, when I'm finding points of intersection, I need to support that with a sketch. That's my work, essentially, to show how I figured out the answers. So I have my exponential function here, and I have my quadratic function that has a point of intersection just to the left of the y-intercept, and then another up in the first quadrant, or in the top right quadrant. So I'm looking for 2 points of intersection here. So again, second trace intersect. I'm already at the leftmost point, so I'm going to find those coordinates, which is negative 0.364 and 0.777. And then for the other point of intersection, it occurs at 2 and 4. So again, when I look at this equation, it only contains x's. So the solutions, even though I use the points of intersection to find them, the solutions are only the x values. So x equals approximately negative 0.364 and x equals 2. So it's really important that you communicate your solutions only as the x values and not as the coordinates themselves. So there's one question. The second question involves a rational function. So here we're given information about a roller coaster ride that follows this model. F of x equals 20 over x plus 2x squared, and we're given a key restriction, which is that x cannot equal 0. So when we're working through this question, we need to know that x is the time in seconds, and f of x is the speed of the roller coaster. So the first question is asking us to sketch the graph. Again, we have a domain to match, which is 0 to 10. So I'm going to first enter the equation into the calculator. And again, brackets for fractions, so 20 divided by x plus 2x squared. And when I graph that, I'm going to change my window to match the desired domain given in the question. So when I go to my window, I'm going to set my x min to 0 and my x max to 10. And then I'll see, okay, I don't need negative speeds, and it looks like the speed will be higher than 10 for the roller coaster. So I'm going to go back to the window, set my y min to 0, and my y max maybe to 100. See what that gets me. Okay. So my function comes down along the y-axis, reaches a minimum, and then comes up again. And I'm going to label this key point, which is the minimum. So I'm going to identify that first with a second trace minimum. And that's going to require going all the way across to the left side. So that's my left bound. I'm going to go back over to the right side for the right bound, and then I get my minimum coordinates of 1.71, it looks like, and 17.5. So that's the minimum point of this function. So B, it asked me to find the minimum value on the graph. I wanted to find that anyway for my sketch. Now when it's asking for the minimum value, it actually wants the y value. So it wants how low does the graph go. You'll notice that the minimum is not the lowest possible value of x, but it is the lowest possible value of y. So we want to communicate that as a y value, although since the question was given in function notation, we'll be consistent with that and say the minimum value is f of x is approximately 17.5 meters per second. We should give units for that as well. So finding the speed when x is 6 is an example of substitution. So we're going to substitute x equals 6, so f of 6, and we're going to calculate that result. So 20 over 6 is 10 over 3, and this becomes 2 times 36, which is 72. So f of 6 is 10 divided by 3 plus 72. And when we get that, we get approximately 75.3 meters per second. And that's the speed after 6 seconds after the ride starts. The last question is giving us the speed and asking for the time. So when you think about your equation or your function, which is 20 over x plus 2x squared, we know that the speed will be 50, and we want to find the times when that occurs. So what we're going to do is we're going to go back to our graph, and whenever I end up in a situation like this where I have a left side and a right side to my equation, I know I can solve that by finding some intersection points. So I'm going to enter in the function as one equation and the y value, or the desired y value, as another. When I go to my graph, I'll see a horizontal line appear. So I'm going to sketch this graph to show evidence for my method, and I'm going to identify the points of intersection. So when I do a second trace intersect, I'll find the rightmost one first, since that's where we started, and that is at about 4.79 and 50. And the next one, if we do another second trace intersect, we can trace all the way over closer to the other point of intersection. And when we do that, oh, a little too far, we get an intersection of 0.402 and 50. So the times when the speed is 50 are only the x values. We don't want the coordinates here, we just want the x values. So x is approximately 0.402 and x approximately equal to 4.79. So those are the times when the speed is equal to 50 meters per second. So those are some examples of polynomial and rational functions, and how you can answer questions and find intersections and solve problems using your calculator.